So, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hilmi bin Fauzi Azam Yahya, and I'm from 3BNA. Today, I'm going to share about what is DC machine and the component of DC machine. So, let's go. So, as we all know, in our daily life, there is so many DC machine, but what is really a DC machine? So, let me explain you a little bit about what is DC machine, okay? So DC machine is a machine that use DC current to operate the machine or the machine that generate the DC current. So DC machine is actually divided into two types. One is DC motor and one is DC generator. So DC generator mainly function is to generate, to convert mechanical power into a DC electrical power, while the DC motor convert DC electrical power into a mechanical power. So basically that is the meaning by DC machine. Okay, let's proceed to our next slide. So what is this, the difference between DC motor and DC generator? So I will explain you some of the biggest uh, difference between DC motor and DC generator. Okay, let's go. So this, of course, the the face, the looks of their component is muchly different. So as we can see here, here is DC motor and here is DC generator. The size also a little bit different. And so let's proceed. So basically, DC motor, we explain about DC motor first. DC motor has a DC current as their input and provide the mechanical output, such as we can see it's in the remote control cars, in the usually many like kipas and fans and others use a DC motor. So we need to power the DC motor in order to work the machine to work. Okay. And DC motor use commutator for changing the magnetic field polarity. So because of the we uh, we supply the current. So if we look at the theory, DC current, if we supply, only produce two polarity, not changing like AC. So we need to use commutator in order to spin the motor. So in DC motor, the commutator is used for changing the magnetic field polarity. So the basic principle that we use inside the DC motor is a Fleming left-hand rule, like this. See? So this is the current flow. This is the force, and this is the magnetic field polarity. So we can determine where is the force is going, whether it's going up or going down. So we are using the left-hand rule as our principle. So basically, the general understanding of DC motor, if we apply more power, so the motor will spin more faster. Yeah. So we explain next is about DC generator. So generator is usually a mechanical and convert mechanical energy into a DC electrical power energy. So if the DC motor use commutator to changing the magnetic polarity, in DC generator, use the commutator in order to cancel the polarization effect. So basically, if you use a generator, the DC generator, the wave came out from the generator is like this. There is no negative side of current. So if we are not using the commutator, the current will be like this. This is a alternate current, so there is not a DC current. So that's why the generator use commutator in order to cancel the polarization effect. Okay. So the principle that we use inside the generator is right hand rule. Just now we use left hand rule inside the DC motor, but in the generator we use right hand rule. Why right hand rule? Because we need to determine the flow of the current. This is the flow of the current. We know the force that we turn the motor at the magnetic field. So the output will be the current flow. Okay. Basically, DC generator is produce a fixed voltage at the rated RPM. So that is the general explanation about DC motor versus DC generator. So we proceed into the DC motor. There's some component inside the DC motor that we need to know. So the first is yoke. Yoke is basically a frame of the DC motor. Then the pole and the pole core, pole shoes, field windings, armature winding, commutator that I said before. In DC motor, we used to changing the magnetic field, okay, and the brushes. So next I will show you one video that explain how the DC motor assemble into one piece. So it will explain all the function of the DC motor. So let's go. So basically this is the picture, cross-section picture. This is pole shoe, this is shaft, field winding, frame oil, commutator, dipole, armature conductor, and so on. So that's okay. This is the video.
Construct the motor.
So
we have both motor.
Okay.
Magnetic frame or yoke. This part acts as a protective cover for the machines and protects the machine from any outside disturbances.
So the magnetic frame or yoke is used to avoid from the machine getting moist or dust anything.
Stator magnets. They are basically electromagnets with such an arrangement so that adjacent poles have opposite polarity. They perform the function of producing the magnetic field. Armature. It is a system of conductors or cord which is free to rotate on the supported bearings. The armature consists of various parts. We will take each part one by one.
So basically this is the shape of armature.
Core. It is made up of high permeability thin silicon.
This is the armature core who holding the winding, armature winding.
And the outer periphery of the core has slots to carry armature windings.
Yes. Yeah.
Next is armature winding. It is generally made up of copper wire.
So you can see the brown one is the copper winding. They're using copper.
Commutator. The commutator is cylindrical in shape and is made of copper. It performs two basic functions. One being collecting the current from the armature conductor, and the other being converting the alternating current of the armature into the unidirectional current in the external circuit with the help of brushes. Brushes. They are usually made of carbon or graphite. And the main function of brushes is to collect current from moving commutator.
So the current will flow into brushes and go into commutator and then go back into the brushes before going to the negative terminal.
Obtain the final output in the form of mechanical energy from the shaft. The armature is mounted
shaft
over
is
the shaft.
The rotating core where when we can put the shaft, we can put the gear into the shaft, we can put a fan to the shaft and so on.
We can now observe in the animation how this motor is practically assembled.
So this is how DC motor is assembled, whether it's small or big. So this is basically the
Now,
frame,
after the
the
construction
design
and
of DC
assembling
motor.
of DC motor, we will discuss the working in detail. Now, when the battery is connected to the DC motor, the current starts flowing through the armature.
See,
A force is developed in the
this is
armature
the basic
due to the
operation
influence
of
magnetic field of
DC
the
motor.
stator, whose direction is given by Fleming's left-hand rule. Now, due to the development of this force,
so
each
this is
armature
where you
conductor,
determine the
the
force,
armature will rotate in the clockwise
whether
direction,
the force will go
and
up
as a
or going
result,
down.
the shaft will also rotate.
Yes. It will determine
Finally, the output power
by
in the
current
form
flow,
of mechanical
and
energy
magnetic
is obtained from the
polarity.
shaft, which is evident from the movement of man in the animation.
So basically that is the base or the fundamental of DC motor. So I will explain you about next about
Construction.
type of DC motor. There's many type of DC motor in our life right now. So there are some types. So start from DC motor, go to permanent magnet, self-excited, separately excited, shunt excited, series excited, and compound excited. So we explain about permanent magnet, shunt excited, series excited, and compound excited for generally. So the permanent magnet motor is used permanent magnet to create a field flux. As we can see inside the video, they are using a permanent magnet to create a flux. This type of DC motor provide a great starting torque and has a good speed regulation, but the torque is limited. So they can typically found in low horsepower application. Basically, this motor is used in a small device like remote control, cars, and so on. Next is the series DC motor. In the series DC motor, the field is worn with a few thin light wire carrying a few armature current. Typically, series DC motor create a large amount of starting torque but cannot regulate speed and can even be damaged by running with no load. This limitation means that they are not good option for variable speed drive application. That means series DC motor is not suitable to use in a variable speed drive like the RC car control. Next is shunt DC motor. In shunt DC motor field, is connected a parallel shunt with a mature winding. This motor offers a great speed regulation due to the fact that the shunt field can be excited separately from armature winding, which also offers a simplified reverse control. So shunt DC motor he have a variable speed that we can use inside the. So we can use it inside the fan or anything. Next is the compound DC motor. Compound DC motor is a shunt DC motor, have a separate excitation field. Compound DC motor have a good starting torque, but may experience control problem in variable speed drive application. So that's all. Between for these four types of DC motor, the potential application are numerous. So each type of DC motor have their own strength and their own weakness. So I hope with my explanation you can understand and may help you in your future study. I think that's all from me. So if you have any question or any inquiry, you can contact me at my Instagram, Ilmife. So that's all. Thank you for watching my videos. Don't forget to subscribe. Okay? Peace.